So today we're going to be talking all about projectiles. Projectiles are one of my favourite things to discuss, and we're going to look at the maths that they involve and how they kind of really link the stuff that you learn in maths and simple equations with your physics. So the syllabus point we're looking at is here. It's describe and explain motion due to uniform velocity in one direction and uniform acceleration in the other. So we're basically comparing the idea of having velocity in one direction but accelerating in another, always perpendicular. That's just going to keep things a little bit simpler. Now the classic example of that is a cannon firing. So in this case it is horizontal, or being horizontally fired. So what that means is we have constant velocity in the forward direction. My cannonball has just a velocity in that direction, and if you think about that from a forces perspective, that kind of makes sense. There will be a little force due to air resistance, so I could put a little friction there, but for most of the time in physics we always ignore air resistance. So when we're thinking about the horizontal velocity, we can essentially say that there are no forces acting on my object. However, when it comes to the vertical direction, what I can say is it has its weight acting downwards, mg. And that's going to be the same at every state. So what that means is, in the downwards direction, I have a constant acceleration. And as we know from previous lessons, we know that acceleration is force is mass times acceleration. I also know that the force due to weight is mass times gravity. So those are the same forces in this case. So ma is equal to mg, the m's cancel. So I know that for most objects, as they fall towards the Earth, they fall at g, or 9.81 meters per second squared. Now, of course, again, in the real world, we do have a little bit of resistive forces. We have air resistance against it falling, but again, we tend to ignore that in the majority of these problems. So we can just pretend that there is no air resistance, and usually we'll get a pretty accurate answer anyway. So, what are the actual solutions for finding these? Well, you can always break these down into two broad categories. The first thing you need to do is find the time taken for the object to fall, and then find the total distance travelled. If you split it into those two steps, you're always going to be fine. Let's do an example then. So we've got a bullet fired horizontally. So here's my bullet, and it's fired horizontally at 400 meters per second. Now, I tend to do an arrow with a line with an arrow in the middle of it to show velocity. So it's fired horizontally 400 meters per second from a gun held 2 meters above the ground. So let's add in the ground here, and then we will add in a dimension to show that this is going from 2 meters above the ground. How long does it take the bullet to reach the ground? So this is a classic example of projectile motion. What I can say is I have a forward velocity of 400 meters per second, and I'm going to have a downwards acceleration of 9.81 meters per second squared. Now, when I draw acceleration, I tend to do a line with 2 arrows on it. That's how I show acceleration. Now, always in physics, we're dealing with vectors, we can choose what directions to make positive and negative. So to make it nice and easy, I'm going to call the downwards direction positive, and I'm going to call the rightwards direction positive. So anything else would be negative. So, if we go back to my steps, I said the first thing to do is find the time taken to fall. So the way that we can deal with any of these problems is I'm just going to split it into the horizontal component and the vertical component. So to do that, I've got my horizontal over here, and I'll do my vertical over here. And in both these cases, I can look at my SUVAT equations. When you do your V, by the way, try and make it a nice sharp V like that, so it's really clear that that's a V. And it's a good idea to put a little tail. That's not very well drawn. Put a little tail on your U, just so that you can see that it's definitely a U, not a V. Because a lot of people, when they're writing these out, they get a bit confused, or it gets a bit hard to see. So what values do we know? So we know in the horizontal component it's going from 0, and I did say that downwards is positive. So its total displacement when it hits the ground in the vertical component will be 2 meters. We're going to be asked later for the horizontal distance, so that's something that we want to know. In terms of initial velocity, well, in the horizontal, we know it starts at 400 meters per second. And we also know that because it's not accelerating in the horizontal direction, its end velocity will be 400 meters per second, and its acceleration is 0. For the vertical component, we know that it starts with an initial velocity of 0, because although it's got velocity in the horizontal component, it has none in the vertical, so that's 0. Its final velocity, we don't know it, and we're not being asked for it, so we can just put nothing there. Acceleration, we've said, is 9.81, and time is something we're being asked for. Okay, so I want to find a equation that has t in it, but does not have v in it. So there's a couple of different ones that I could use. I'm just going to go for one that I just remember off the top of my head. S is equal to ut plus a half at squared. So with that, I can say 2 meters is equal to 0 times t plus a half times 9.81 times t squared. So this becomes 0, so multiply by 2, 4 over 9.81 is equal to t squared. So t is equal to the square root of, let me just open up my calculator, so that will be 4 divided by 9.81, that's 0.408. So t is equal to the square root of that, which I get as 8.4 seconds. That can't be right. What have I done there? Oh, sorry. It's because I've got a weird answer on my calculator. I didn't press enter on my calculator. Little bit of example there. I could see that 8 clearly can't be correct because it's far too long for it to hit the ground, and also doesn't make sense. The reason that was wrong was, I hadn't pressed enter, so the answer memory on my calculator was wrong. That sounds more like it. T is 0.64 to round, 0.64 seconds. It's about half a second to hit the ground. Okay. So now I've got t. So t is equal to 0.64. So now that I know how long it was traveling for, it's kind of going to be following this sort of path. So now I can calculate the vertical distance. And you could just use speed as distance over time, but I don't think that's a very safe thing to do. So a better thing to do is to go to really any other equation that you have. So for example, you could just go to the same equation again actually. S is ut plus a half at squared. So S will be equal to my initial horizontal velocity now, which is 400, plus a half times 0 times t squared, which is 0.64 squared. Realize I forgot to multiply by the t here, so that's times 0.64. So this side collapses to 0. So S is, let's hope I've done it right this time on my calculator, That looks about right. 255 meters. There's my answer. So there you go. That is how we deal with any kind of projectile motion question. You split it in half. You deal with your vertical component first. That's how long it takes to actually hit the ground. And then you use the time component to find out the time. If you think about it, it's going to keep going forward until it does hit the ground. Therefore, we can use the vertical to find out how long it was doing the horizontal for. Stop the video there. We're going to have a little couple of practice questions on that with just firing horizontally to begin with. Okay, so last time we were talking about firing completely horizontally. Let's just turn that on its side. See what I did there? Turn it on its side. And we're going to deal with firing something straight up. So here's my cannon, and it's on the ground, and we're going to fire it straight up. So if you imagine the path that a cannonball will take in this instance, it's going to go up, slow down, slow down, slow down, and then crash back down to Earth. And we have no horizontal components, so it won't go from side to side. So a classic question would be, well, how long does it take to go up and then come back down again? Well, let's think about our suvats then. So our total displacement, how far has it gone? Our total displacement is 0, because remember displacement is a vector. So it's a distance, it's a total distance from our start point. When the cannonball crashes back to ground, the displacement is 0. U I've been given, that's 100 meters per second. V, I don't know what that is. Later you'll see that it's actually very easy to tell what it is, but for now let's say I don't know. A is 9.81 meters per second squared, and T is the thing I'm going to find out. So I'm just going to change that V to a cross because I actually don't need it. What equation am I going to use then? Well, our old favourite, S is equal to UT plus a half AT squared. When I do that, I can then plug in my numbers, so I can say 0 is equal to 100t plus a half times 9.81t squared. Now I can simplify that a little bit. I can say if I just move the t squared first, so that half of 9.81 is 4.905 t squared plus 100t, that's equal to 0. Now hopefully you remember from maths, this formula, this is the quadratic formula. So you don't need to really remember the maths, you can just plug numbers straight into here. And when you do that, you will get two answers. You will get 0 or you will get 20.4 seconds. Now, that's telling you the times at which the cannonball was at 0 displacement. And that kind of makes sense. It was at 0 displacement at the instant it was fired, because it started from 0, and it comes back to that point again. Is it worth it? Yeah, let's just show you that in the steps just so you can be clear. Minus b, so that would be minus 100 plus or minus the square root of b squared, which is still 100, minus 4ac, well, c is 0, so that would be minus 0, all over 2a, so that would be 2 times 4.905, so that would be 9.81. So this then becomes minus 100 plus or minus the square root, sorry, that should be 100 squared, the square root of 100 squared over 9.81, so that is minus 100 plus or minus 100 over 9.81. So you can see minus 100 is minus 200, so that would give me a negative answer, but it will be minus 20.04, or I can get minus 100 plus 100, which would be 0, 0 divided by anything is 0. What's the significance of the minus sign? Absolutely none whatsoever in this case. Now I know that's going to hurt some of you that think mathematically, but it's, well, you can think of it in terms of, well, what is acceleration? If I made my acceleration negative, then this would have all changed and I would have got a positive answer. But really, for physics, just be intuitive about it. We know the cannonball isn't travelling backwards in time, so it makes no sense to have a negative time. If that upsets you, have a chat with me, and we can go through kind of the significant, like the sign does have some significance, but it's really, really minimal. So I don't want the majority of you to worry about it. I don't think it's useful to think about it. But that's the dead simple way of doing that. All right, so let's now look at the trickiest thing we can do, which is when we fire at an angle. So let's say I'm firing this at the same speed again, but now I'm at an angle of 45 degrees. Well, if you remember from maths, when I have a vector of length 100, I can split that into two. I can have, so this is my velocity, this is my total velocity, and I usually use a capital V to show that this is, I mean, I suppose that really it should be U, shouldn't it, because it's the start. So let's say that. There's my U. I can split that into two, and I can give myself an initial velocity in the horizontal component, and I can give myself an initial velocity in the vertical component. Now I know that this is an angle of 45 degrees, so suddenly this has just become a trigonometry problem. And if you remember this rule, so car toa, well, there's my angle. So U is the opposite, V is the adjacent, and 100 is the hypotenuse. So if I want to find, remember we always say in all these problems, you find the time taken first. And to find the time taken to hit the ground, we always use the vertical. So I want to say, how long does it take it to go up and then come back down and smack on the ground? So I want to know, what is the velocity of this cannonball going straight up? So I'm going to need the opposite and the hypotenuse. That means I'm looking at sine. So from SOHCAHTOA, that means that sine of my angle, which in this case is 45 degrees, that is equal to the opposite, which is UV, over the hypotenuse, which is 100. So that becomes 100 sine 45 is equal to UV. If I wanted to find, that's for the vertical, let's split up this. For the horizontal, well, for that I want the adjacent and the hypotenuse, so I can say that cosine of 45 is equal to the adjacent, which is UH, over 100, so that becomes 100 cos 45 is equal to UH. Now there's a general rule that you can remember for this. Sine is a stretch, cos is a crush. What does that mean? It means if I have any vector and I want to split it into horizontal and vertical components when it's got an angle, to find the horizontal component, so to find that, I'd have to take this 45 and stretch it out. So I can do 100 times the sine of the angle. Yeah, sine stretches the angle open to get the horizontal bit. If I want to find the horizontal, sorry, that's the vertical bit. If I want to find the horizontal bit, I need to crush down on that angle. So I'm going to do 100 times cos of 45, and that will give me the horizontal component. Anyway, I need to find the time as always, so let's start with that. So if I plug that into, do this calculation, I get that my initial vertical velocity is 70.7 meters per second. So then I can plug that once again into my old friend, S is equal to UT plus a half AT squared. Again, I'm just going to draw on here, the acceleration in the vertical is still 9.81. That's always acceleration on Earth. So I can say that 0, because that's my total distance, it's gone up and it's crashed back down in the vertical. That is equal to my initial vertical velocity, which is 70.7 times the time, plus a half times 9.81 t squared. If I plug that into the quadratic formula, I get two answers, 0 or 14.4 seconds. Obviously, I'm not interested in it right initially, so I'm going to be using this as time. Then if I come over to the horizontal component, well, again, plug this into the calculations. I get this exactly the same answer, actually. It's 70.7 meters per second. That's u in the horizontal component. So plug it into my equation. S is equal to ut plus a half at squared. A in this case, so if I do it this way, a in the horizontal, that is 0. So this just becomes 70.7 multiplied by the time that I got earlier, so that's 14.4, and that comes out at, using the same number of significant figures as in my question, 1,000 meters. So there you have it. Even when you do things at an angle, you can just plug this straight into these kinematics equations. Find out the vertical component first, wait for it to go up and come back down, find the time taken to do that. Then, because it's not accelerating in the horizontal component, you can just do time multiplied by velocity.